Hi guys, welcome to the today's session on design and analysis of algorithms. In this session, we are going to discuss about Bellman fold algorithm. Belongs to the module 15. So here we are going to see what is the purpose of using Bellman fold algorithm. What is this algorithm? What is the main principle behind this algorithm? And how to find the shortest path using this Bellman fold algorithm by taking an example. That is, we are going to solve an instance, right? So first of all, what is this Bellman fold algorithm? Bellman fold algorithm is a single source shortest path algorithm that determines the shortest path between a given source vertex and every other vertex in the graph. That is, so here you have a graph. Let us say your graph is present. This is having some number of edges, right? Like this, your graph is present. So the Bellman fold algorithm takes one vertex as the source vertex, and it considers all the remaining vertices as the destinations, and it goes for finding the shortest path from the source vertex to all destinations. All destinations. So this is to be called as a Bellman fold algorithm. So these algorithm works for both weighted and unweighted graphs, right? And we can use Distress algorithm for finding the shortest path. So here we can use Distress algorithm for finding the shortest path. But this Distress algorithm doesn't work when the graph contains negative cycles. That is, if the weight of any edge is negative, then Bellman fold algorithm doesn't work. Sorry, Distress algorithm doesn't work. But the advantage of using Bellman fold algorithm is that it guarantees to find the shortest path even your graph contains negative edge weights. Even your graph contains negative cycles or negative edge weights, Bellman fold algorithm finds the shortest path from source to all destinations. The main idea behind Bellman fold algorithm is that it works on the principle of relaxation. The Bellman fold algorithm works on the principle of relaxation. What is this principle of relaxation? So here, it starts with a single source and calculate the distance to each node. The distance is initially unknown and assumed to be infinite. But as the time goes on, the algorithm relaxes those paths by identifying the fewer shortest paths. That is, for example, your graph contains these three nodes. So here, the paths are like this. So initially, the distance of this one is infinite and the distance of this one is infinite. These two are the destinations and this is the source. So later on, in the next iteration, it goes for finding the distance of this one by relaxing this path and by identifying a new path which gives less cost. Right here also, this goes for relaxing this path by identifying a new path which gives less cost. So like that, Bellman fold algorithm works that identifying the fewer shortest paths, that principle is to be called as principle of relaxation. Right. Now, how principle of relaxation can be applied means, if your graph contains n vertices, all the edges should be relaxed for n minus 1 times to compute the single source shortest path problem. All the edges should be relaxed for n minus 1 times. In order to detect whether a negative sign exists or not, So here, the relax all the edges one more time. So if I first for finding the single source shortest path, we need to do for n minus 1 times. If I do one more time extra, that is if I do the nth time also, I can find whether the negative cycles exist or not. So how I can find means, if we relax the edges n times, there is a change in any shortest distance of any node between the n minus 1th relaxation cycle and nth relaxation cycle. Then we can say that a negative cycle is exist. Otherwise, there is no any negative cycle. So from n minus 1, if I stop the process up to n minus 1 cycles, then I can get the shortest path. If I continue for one more cycle, in the nth cycle, if there is a difference in the path cost from n minus 1 cycle to n cycle, then we can say that there are negative cycles. Otherwise, we can say that there are no negative cycles. Right. Now here, I'm going to play a small video which shows the Bellman algorithms process. So try to understand it. After seeing this, we can go for solving a small example which better understands it. Right. See this. So I hope that somewhat you understand how the edge initially all the edges are present at a distance of infinite. Later, how they are changed by finding the shortest paths. So now we are going to see some example, some instance to solve this a single source shortest path problem using Bellman algorithm. Now here, what is the formula that we follow for relaxation means? Here, this is the formula that what we follow. If d of u plus c of u comma v is less than d of v, then d of v is equal to d of u plus c of u comma. So what this formula tells is, u is a vertex, v is another vertex. There is an edge from u to v, let us say. Now, the distance of u, initially we have a distance for the vertex u, and we have a distance for the vertex v, and there is a cost assigned to this edge. Let us say it is WUV, weight assigned, which is nothing but cost of this edge, cost of u comma v, which is equal to weight assigned to this edge. Now, if I add the distance of u with this cost, if all this value is less than this distance of v, then we will update this distance of v value with this value. I hope that you understand. Now, once again, I am saying you that u is a vertex. Let us say its distance is 5. V is another vertex. Let us say its distance is 7. Now, cost of u comma v, which is nothing but weight assigned to this particular edge, uv. Right. Now, 5 distance of u plus cost of u comma v, that is 1, less than distance of v. If this condition is true, what becomes the distance of v? 6. Since this condition is true, the distance of v becomes 6. That is, this 7 is updated as 6. That is, we are relaxing the path which contains a cost 7. Initially, we find a path whose cost is 7. Now we are relaxing that path by finding another shortest path. Right. So like that, we go for relaxing the paths in case of Bellman algorithm. Now here we have taken an example, let us see, which contains 6 vertices. Those 6 vertices are represented as A, B, C, D, E, F. And some vertices are having negative cycles, negative weights. Now here let us see the weights are assigned to each edge. Now, what is the initialization condition for Bellman fold algorithm? We need to consider one vertex as the source vertex. So here I am taking this as the source vertex and all these remaining 5 as the destination vertices. And the distance of source vertex initially is to be taken as 0. And the distances of all remaining, that is destination vertices, are to be taken as infinite. Now we need to take all these as infinite. This is the initial condition that what I need to do in case of Bellman fold algorithm. Now from here onwards, we need to perform, since my graph contains 6 vertices, I need to go for 5 iterations for finding the single source shortest path problem. That is the shortest path between the source to all vertices. Right. Now here, let us see the edges which are present in my graph. Here I have these edges in my graph. Now I am going to apply the relaxation method for all the vertices by considering one by one. Now in the first iteration, first we are considering the edge A, B. So here A is U and B is your V, right? Now we are going to find the distance of V by using this U. Now initially distance of U, that is distance of A, is 0, right? Now distance of V is V, here V is V, whose distance is infinite. And here you can have the weight 6. Cost of U V is 6. Now let us add this. Distance of U plus cost of U comma V. What is that one? 0 plus 6. Is this less than the distance of V or not? Yes, 6 is less than infinite. So what is my distance of V? The distance of V is updated as 6. So here this infinite is updated as 6. Right. After that I am taking the another edge AC. Now distance of U is 0, distance of V is infinite, cost of U comma V. What is this cost? 4. Now 0 plus 4, that is distance of U plus cost of U comma V, that is 0 plus 4 is less than infinite. So the distance of V is also updated as 4. Right. Now in the same way, we go for taking the remaining edges as well. I taken AD, I taken the edge BE, we taken the edge CE, we taken the edge DC. So we need to follow the same procedure, right? Now here also the remaining edges TF, EF and CB, all those we calculated and we updated the values as like this. After the first iteration, the values are updated as at B, distance of B is updated as 1, distance of C is updated as 3, distance of D is updated as 5, and distance of E is updated as 5, and distance of F is updated as 4. Right. Now, next, in the second iteration, again, I need to do the relaxation for all the edges what we have. Right. Now, again, I am considering from AB. So, it is not relaxed here since I already relaxed the I already find the distance of B as 1, but here I am getting the distance as 6, so which is greater than 1, so that's why it cannot be updated. Now in the same way AC and AD, both cannot be updated. Next I can go for BE, whose distance is updated to 0, and here the distance of CE, here also no updation. And here we check each and every one. So all these edges, in all these edges, there is no updations. Now, after the second iteration, how my graph is looking like this. Here the value distance of B is updated as 1, distance of C is updated as 3, distance of T is updated as 5, distance of E is updated as 0, and distance of F is updated as 3. Right. Next we go for third iteration. So we will observe that if we repeat the same steps, the distances are not updated, and in the fourth iteration and in the fifth iteration as well, the distances are remaining same only. I already calculated all these things. So that's why finally we can take the shortest distances as 1, 3, 5, 0, 3. Right. Now what may be the path here from A to B? Which path gives the distance 1, which path gives the distance 1? Let us see. If I go from A to B, sorry, A to D, from D to C, and C to B. Let us see. A to D cost is 5, D to C cost is -2, and C to B cost is -2. So what it becomes? 5 minus 4, whose value is 1. So here the path is A to D, D to C, C to B. Right. Now coming to C. What is the cost coming to C? Here A to D, D to C. Here you can see 5 minus 2, which becomes 3. Right. Next D. Coming to D. So D is present here. So distance is 5 I am getting. That is, this is a direct path. A to D. Right. Next. Coming to E, whose distance is 0. Coming to E, whose distance is 0. So how I am going for this is A to D, D to C, C to B, and B to E. So up to here, I am getting a cost of 1. Here the weight is -1. 1 minus 1 becomes 0. Right. And coming to F, F is 3. So how can I get the cost 3 here? I need to move A to B, D to C, C to B, D to E, and E to F. This is the path that I have. Like that, I need to find the path as well. Right. So this gives you the Bellman code algorithm. I hope that you all understood how to solve single source shortest path problem using Bellman code algorithm. So thank you for listening. Thank you.